Right, hi everybody. Here's question 139 from chapter 3. This question gives us a molar mass of a compound and tells all the species that are in it, that being carbon, hydrogen, bromine, and oxygen. And also tells us that the compound contains 8 times as much carbon as hydrogen by mass, and then asks for the molecular formula. Now, questions like this are multi-step puzzles. I quite like these sorts of questions, really. The idea is that you have to remember to think of the formula weight of the compound as the sum of all of the formula weights multiplied by the molar coefficients. So in this case, like that's going to be all of the formula weights for the molecules present. So there's carbon times some coefficient plus hydrogen was another one, right? Times a coefficient. Plus oxygen times another coefficient. And the last was bromine. Bromine is 79.9. Right? Times another coefficient. And this whole thing is going to sum to 177 grams per mole. I'm taking the grams per mole unit out of this because each of these here would also have units of grams per mole. So we can factor that right out. And what we really need to do then is solve for each of these coefficients one by one until we can put the whole puzzle together. So let's just write ourselves a little legend up top here. And we'll plug all these things in as we go. We are going to need that. We're going to need that relationship between carbon and hydrogen. We'll write that down. We'll write that down and use it in a later step. Usually, when you have questions like this, there's one that you can kind of that you can solve for right off the bat, and it's usually worth looking at the heaviest one to make sure that you can actually fit more than one of these in there. And in this case, we see this is not the case. So we know that D has to equal 1, right? And we know that because 2 times 79.99 is a greater value than the entire molar weight of the whole compound. So we know that that has to be equal to 1. So we're going to revise our formula then to whatever we're left with after we eliminate that. C equals, so it's going to be 177 minus 79.9, and that gives us 97.1. Right, and again, that's 1 times this subtracted from this. Okay, so next we're going to use that. Carbon and hydrogen relationship. And if you recall, that said that the mass of the carbon was equal to 8 times the mass of hydrogen. Like that there. So what we can do then is we can write carbon in terms of hydrogens like that. It's 8x, where in this case x equals, goodness, that's bad, x equals this here. All right, really it's gonna end up being equal to b, because this is just going to be the coefficient for the hydrogens. But what it means is that we can abbreviate these two terms here into 9x. We have the 8x and then the 1x here. So we're going to condense these two things into 9x with that. Where I will draw a good x one of these times. Okay, so now we have 9x plus 16c equals 97. 97.1. Okay, so what we want to find now is we want to find C such that if we subtract some multiple of 16, we're left with something that we can evenly divide by 9, right? This has to be good Lord. This has to be some sort of x, like such that x is an even integer. Right, like as in it's got to be 1, 2, 3, whatever. It can't be a fraction, right? We can't have fractions in the molecular formulas. So we're going to plug in a guess value for 16 that satisfies that consideration. We can see here, just looking at it, that if we subtracted 16 from this total, we would get 81, which we can divide by 9 evenly. So we're going to try that one as a first value, and if that doesn't work, then we're going to go back and fix it. So we'll put a question mark there just in case that doesn't work out. All right, and that means that 9x equals 97 minus 16, which gives us 81.1, meaning x equals 9, more or less. Okay, so that means that we get a B value out of this too. We have 9 hydrogens present. We're going to put a question mark at that because that depended on that guess value of C. Okay, so now that we've got that in place, we're gonna reverse engineer our carbon out of that. So again, it was like the carbon was equal to 8 times the hydrogen, right? So that means that 8 times our hydrogen figure has to be equal to the mass of the carbon present, right? So we're going to solve for A then with 8 times whatever X was, which is B, which is 9. And we're going to divide that by 12.01, right? And that gives us 72 over 12, which is 6. And so we know that all these things check out because we got even integer values for all of these things. And then we write all of our species with each of the right coefficients. So we get 6 carbons, 9 hydrogens, and then 1 each of bromine and oxygen. And that's our molecular formula.